Here we go. Welcome to Tabor Institute's webinar, How to Perform Cost Risk Analysis in Risky Project. My name is Michael Trumper. I've been part of the development team for Risky Project for 15 years and one of the principals at Tabor Institute. In this webinar, we'll look at the various methods that you can use to perform a cost risk analysis on your projects and the various charts and reports that will help you identify the main cost drivers in your project and how much contingency is required to account for that risk. The webinar will include theory and then a live demonstration. We'll be recording the webinar and it will be available from our site later this week. However, before we start, I'd just like to go over some housekeeping. Here are the housekeeping slides. We have some directions that go with it. As an overview, we will look at how we can include model cost risk. Cost risk differs from schedule risk in that the resource is at an additional level of complexity depending on the types of resources. Cost analysis includes views of the statistical analysis with histograms and cumulative probability, which show a risk-adjusted cost and contingencies that may be required to account for this unmanaged risk. Sensitivity shows which risks and activities are the main drivers of risk variance, and cash flow provides insight into how costs may be generated probabilistically over the life of the project. Two sources of risk is uncertainty and risk events. When creating a cost risk model, we can apply two types of risk to our costs: uncertainty and risk events. Uncertainty is characterized by 3-point estimates, low, most likely, and high, combined with the statistical distribution. Uncertainty can be applied to both duration and cost for the purposes of cost analysis. Risk events are sometimes referred to as risk drivers and are characterized by a probability of occurrence and impacts. For cost risk analysis, both fixed cost and schedule impacts can be used. Here we show how we can apply uncertainty to a fixed cost. The base or most likely cost is $1,000. The lower optimistic is $950, and the high or pessimistic is $1,100. A visual representation of these estimates with a triangular statistical distribution is shown on the left. On the right, we can see the results of an analysis using two different types of statistical distributions. These different distributions can affect statistical measures like standard deviation. On the top example, we can see that the triangular distribution has fatter tails, or results have a higher probability of landing farther from the most likely value than in the log normal distribution on the bottom. Risk events and fixed costs. Risk events are risks that are found in the risk register. They have a probability of occurring and an impact. Probabilities are between 0 and 100%. Impacts can be fixed or relative. Impacts can be a discrete value or can be modeled as an uncertainty with a range of values defined by a statistical distribution. In the first example, with a discrete impact, the risk appears as a single bar in the histogram. In the second example, with a ranged impact, the risk appears as a small distribution to the right of the base estimate. As we can see, the way that we choose to model the risk can have a significant impact on the results. Work is the fundamental unit of the time-dependent cost calculation. Work is a function of the resource allocation. Resource units indicate the level of allocation or percent of the activity duration that the resource will be working on an activity. For the purpose of this discussion, we're using the commonly used fixed unit task type, which keeps resource allocation units fixed and recalculates work if duration is modified. We will discuss the appropriate use of other task types in future webinars. In this example, we can see how the base cost for a resource assigned to a task is calculated. If we lower the max units to 50%, the work performed by the resource over the same period will be reduced to 20 hours at a cost of $2,000. The other thing to take a note of is that the duration changes work and therefore resource costs are adjusted accordingly. In this way, resources can be used to model time-dependent costs. Time-dependent resource costs. Resource costs can be risked as part of an integrated approach to both cost and schedule risk analysis. Both schedule uncertainty and risk events impact work-related resource costs. In these examples, we have used one resource with an hourly rate to show how schedule uncertainty and risk generate cost risk as presented on a combined histogram and cumulative probability chart. They look very similar to the results that were generated by the cost uncertainty and risk event models that's shown in the previous slides. If we can represent resources and fixed costs, you might ask, why should we use resources? A couple of reasons. Activities can have more than one resource assigned to them, and accurately representing these costs can be more difficult without using resources. Two, the cost resources can also be affected by non-scheduled risk. These risks are assigned directly to resource and are called rate or cost increased impacts, where we can apply either a relative or fixed impacts to the resource rate or material cost. In this way, you can account for uncertainty in labor rates or material costs. Rate risks are assigned in the Resource Information dialog box Risk tab. In this example, we applied a rate risk increase to a resource that is assigned to a task. Once a task has been assigned to the resource, the risk is applied or broadcast to all of the activities to which this resource is assigned. Here, the impact of the rate risk is shown on the combined histogram and cumulative probability plot for a single task. Material cost calculation. Another type of resource is material costs. Like resource rates, material costs are not based on work and therefore not time dependent. Material resource costs are calculated based on a rate per unit. For example, in a particular activity, you would have material costs at X dollars per ton. The material resource value is assigned to an activity with a unit value. The cost is then allocated to the activity based on the rate and the number of units. Material costs are treated similarly to a fixed cost when it comes to risk events. Material costs can be risked using the outcome type fixed cost increase. Relative cost increase outcome types does not work in this case. In this example, we can see how we can apply a range of possible rates for the material and its presentation on the chart. In addition, if we're using cost type resources, which are similar to material costs, cost type resources can be risked for each specific activity using the same method. Cost summary view. After running a Monte Carlo simulation, two of the most popular reports are histograms and cumulative probability. In this particular example, we have combined a histogram and a cumulative probability chart. On the left y-axis is the probability. We can see that the most likely value occurs 9% of the time. On the right y-axis is the cumulative probability values with markers placed at 10 percentile, mean, and 90 percentile. Cumulative probability is useful for setting cost contingency, which would be the difference between the deterministic value, the red line that we have on this chart, and a cumulative probability with a higher confidence level, such as P90 on this chart. In addition, we can plot multiple cost scenarios representing different risk management strategies as cumulative probability plots. In this particular view, we are looking at a pre and post mitigated baselines. The cost chart provides a view of the forecasted cost of a project over time for deterministic and risk costs. As we can see, because the project has a high probability of running longer, it will cost more. If there are actual costs, they will be plotted on the chart, and project cost control indicators are displayed at the bottom right. Cash flow. The cash flow chart shows probabilistic cash flow over set periods, months, bi-monthly, quarterly, or annually. In this particular view, we can see that for the period of February, there's a high probability that costs will be well above the current forecast due to risk. In addition, we can see that because of the delays, the project should expect to experience 2 additional months of costs. Because February shows a large jump in expected cash flow, we can take a look at a detailed view of the probabilistic cash flow for that particular period. The large spike on the right is due to a probability of a critical risk occurring. Sensitivity analysis. Sensitivity analysis, or tornado charts, provides insight into which tasks or risks have the most potential to drive costs in the project. On the left, we have a list of tasks ranked by how much the risks and uncertainties impact the cost of the project. On the right, we have the simulated ranking of risks. It's extremely likely that the highest ranked risks are assigned to the highest ranked activities. To minimize potential cost overruns, we need to focus our risk management efforts on these tasks and risks. task, total cost, and variable costs. In the previous views, we've been looking at project level analysis. However, it's possible to drill down to the activity level to view the cost analysis. On the left, the chart shows the probabilistic total task cost. Of note, the histogram is bimodal, which shows the two distinct distributions. The one on the left is due to uncertainty or natural variance, and the second to the right is due to a serious risk event occurring that has been modeled using a statistical distribution. The chart on the right shows similar results, but for resource costs. In this chart, the second distribution is even more distinct, so that we know that the risk is tightly correlated with the resources allocated to this activity. If we'd like to further investigate the source, we can look into the specific variable work and therefore cost for each resource allocated to a specific task. This particular view, which is very tightly correlated with the previous results, would indicate that in order to control costs, we need to focus on this particular resource as being the root cause of the predicted cost overruns in this activity. We're now going to take a look at the live demonstration of how we can model these particular costs. In this view, we have set up 7 different types of cost risk analysis. Time independent fixed costs. The first one we'll just be using cost uncertainty. And the second one we'll use cost risk events with a single outcome. The third we'll have a risk event with a distribution. In these time-dependent costs, where you're going to use schedule risk and schedule uncertainty to model this. And we can see here, we don't have any uncertainties in schedule, and here we do have an uncertainty in schedule, and that will drive the cost because we're going to have a resources assigned to these. I'll just drag this over so we can see the resources. So we have a labor resource assigned to this, and then we're also going to show you how we can do a schedule risk and how that will drive cost because of these resources that are assigned to this. And then we'll look at the rate risk, and then we'll look at a material cost risk. And we can see the resources that we're using in this system. We have hourly rates or material costs. We have 3 different ones that we'll use. We're using on the schedule risk, and this one we'll use as the rate risk. On the cost and income, the only ones that we're doing on the fixed costs, these are the values that we're going to be risking on for fixed costs. All the other ones, all of the costs are coming from resources, which we can see right here. So in this particular one, we're using cost uncertainty. We're using these 3 values. That should be $1,000. And we'll go 1,300 to add that. So we can add it manually, and it will be, if we want, we can add it using risk bands, cost risk bands, or we can use these low-high durations, which allows us to calculate it based on this. But we are just going to apply that to it. And see what that looks like is if we go to the distributions tab on the task information, we can see that triangular view again, and that's how that's being modeled. It's skewed slightly to the left, slightly to the right, sorry. On the cost risk event for a single outcome, if we go in here, we're going to take a look at it, and we'll go to the risk tab. We'll see we have this cost risk. It's got a 50% chance of occurring with a uniform outcome of $500, so it's a single outcome. And we'll see how that turns, and then we're going to show it with a risk event with a distribution. We'll look at that same risk tab. If we can enlarge that, again, we're going to have 50%, but this time we're going to have a statistical distribution modeled with a low, most likely, and high outcome for that risk event. Now, if we go to the cost schedule uncertainty, the way that we're modeling this is if we go to the distributions and we go to duration, we can see that we have this same triangular distribution that we applied with a low duration of 3 and a high duration of 8. On this cost schedule risk, we'll go to the risk tab in the task information. We've assigned this risk, schedule risk, with a 25% chance of occurring, of a relative delay, and with the low, most likely, and high outcome. Finally, we'll take a look at the resource risks. In the first one, the cost rate risk, we take a look at this. That risk has not been assigned to this activity per se. Where it's been assigned is in this resource. And this resource, it's been assigned to this one, and we can see right here. And that one should not. Okay. And we've assigned a rate risk. So we call it rate risk, and we select rate risk. That's the only outcome that will work on this, and we're going to give it a 100% chance. So what we're doing is we're putting basically it's an issue. We know that it's not so much of a risk, but we know there's going to be variance in the rate risk. So we've given it 100%, and it can be less by 5%. We think most likely it's going to be 5% more than what the rate is right now, and it could go all the way up to 20% using a triangular distribution. On the material resource, we're going to be risking this amount. This material resource has been assigned to the material cost risk, and if we look at that, we can see it right. We can see it right here in the resources. It's been assigned here. And it's got 1 unit. So 1 unit of 1,000 equals, and if we go to the cost and income, we can see it's getting $1,000 because of that. Just to go back and take a look at that, if we go back to that view, and we added that 2 units, I'll give it 2. That'll be quicker. And we go back to that resource cost, sorry, cost and income, and the resource cost, we can now see that's $2,000. So 2 units of 1,000 on this particular activity is going to create $2,000. Now, the way that we're going to risk that is we've called the risk material cost risk, but it is a fixed cost increase. And we're just going to give it $100 on this, a 60% chance of occurring with $100 outcome. So we'll see probably about $2,200 of when the risk occurs. So once we've done that, we can calculate. So we've calculated, and now what we're going to take a look at, we can look at the summary. One of the things when we want to look at this, one of the things we want to look at is the low and high. The high duration is basically, we want to see what that costs on there. So one of the ways that we can set, what does high mean? It's a percentile value, and we can use that as the setting, the high setting, as the contingency level, risk-adjusted contingency level that we want to create contingency at. We can go to the schedule, go to project options, go to calculation, and we can go here and we're going to set a custom percentiles. And this is telling us when we look at the results, what do low and high mean? And here we're going to put it at P80. So when we look at this analysis, we've got high, and we can see that the high P80. Now the difference at a project level, if we're going to build in enough contingency to cover the unmanaged risk, is the difference between the current schedule and the high. So in this case, we'll need about $2,400 of contingency. Typically, we're not going to set it up at that level. We want to see it here. We can see how that's being brought up here. So our contingency would be the difference between the deterministic and the P80. Now, really, what we can do is then take a look at the analysis for each one of these. We'll see how the costs and how the different modeling appears on this. We can go to the result Gantt. We'll click that. We'll go over to the analysis view here, and we'll just click probability. And we can click here, and we can see how this cost uncertainty is shown. So we're getting that nice triangular histogram that we saw with a nice curve here. And we can see the difference between the P80, the most likely that we had here, which is $1,000, and the P80, and we can see that's $1,100. So in this particular activity, we'd put in $163.96 of cost contingency if we were using P80 as our value. Now we have a cost risk event, and as we saw that, we modeled it again like this, and then if we look at it, if we look at it, we see that single spike, 50% occurring of that risk occurring, and we can see it goes from $100 to $1,500 because we have that $500 chance of it occurring. So it becomes two single spikes on there. If we look at the cost risk event with a distribution, we can see that without the risk occurring, that's the deterministic, and here's where that risk occurring. We're seeing that long sort of triangular distribution, which is really what it is here, stretched out over here. And then this actually, if you look at that, then we require a bit more contingency because of the way that we've modeled it. And this is probably more realistic, that when a risk occurs, that there's a range of what will happen when that risk occurs, and we want to sort of account for that. Now, if we look at the cost schedule uncertainty, so this is just, we're using the 3 to 5 to 8 days with a labor rate on it. There's no fixed costs. We're driving that, we call this time dependent costs. And here we see that looks very similar to with the fixed cost uncertainties. Again, but what this is being driven by the resources, which we can see if we want to. We can see these are the variable costs for that particular thing, which is exactly the same as what we saw because we have one resource, only one resource, no other sources of costs associated with this particular activity. And the statistics will look very same for the work. So that's our probabilistic work for that activity. So cost schedule risk, again, we have a single risk impact. And we can see that if we go over to here, we can see that risk impact. And we can see, again, we have a single risk with that distribution. Risk not occurring, risk occurs, and we get a distribution on that. We get this sort of odd looking chart, but it's just showing what. And then here we can see that on the P80, we'll have about $1,275, let's say, of contingency between the deterministic and the P80. Now, the last ones, we're looking at time independent resource rate risks. So the cost rate risk that we had, so where we had risked, we put a cost rate risk on the resource, on the labor resource, that gives us this sort of value right here. So it was, the base value was $2,000 and we had it 5% less, all the way up to 20% more, which would get us around $2,400 with a bit of a statistical distribution that goes from the 5% most likely, which is about here, and then comes down again. And the material costs, if we're risking the material costs, and we look at that, we can see that we had it once, and like I had mentioned, because it was $100, it was happening 60% of the time. We get that $2,100, and it looks like we would need $100 for our contingency on that. This is fairly simple. Obviously, this is not realistic. We'll just switch over and we'll take a quick look at this model. Now, this model, it's a project plan that has a lot of different risks. It's mostly the risks, costs have been driven by resource costs. We can see that if we go into here and we go into cost and income, we can see that really we don't have any fixed costs, but it does give us an idea about how we can look at all the costs all the costs in the system. So these are not the unrisked resource costs that we have in the system. So if we we'll go back to the analysis, and we want to look at the project summary again. We'll take a look at it here, and right here we've actually got a pre and post mitigated. You can see right here there's a big risk that sort of occurred. And we did some mitigation around that sort of jumped that away, so we are able to put in a pre and a post mitigated, pre and post mitigated. We can look at that. We've got our we'll just check that back onto there, and we've got our P80 right here. And again, so we can look at our contingency. We'd be looking at our post mitigated for our contingency versus our deterministic. And one of the things, again, we're looking at the, we can go and just make sure that we have that set up correctly. It'll ask us to recalculate because we've changed the definition of what those are. So at the project summary, we can see that, and we can see the multiple S curves on there. Double click to get that detailed view up. Now the cost analysis, as we'll see, let's drag this over a bit more. Because the project is going to take additional time, we can see as it goes, it's going to take longer, it's going to cost more. And if we drag across, we can start to see basically some cost control variables. If we go to the cash flow shows us the expected cash flow over time. We can see what's happened here is because we have delay, which is an interesting thing, is that we expected to be spending this money here. It turns out we're going to be spending it here and more than expected. And then as the project goes longer than expected, we're going to be having this extra costs in this particular period. So we've got a monthly if we want to. We're looking at February. We can double click on that and bring up that cash flow or the expected costs for that particular month. And we can see right here, this looks to be that there's a risk event that's occurred that's causing us to drive this particular cost in February. Seeing that very high spike. Sensitivity analysis, we always like to take a look at it. So we're going to look at cost, and we're going to look at task costs on this particular one. And we can see that these ones all have about the same. I'm just going to switch this over so we can look at the contribution to variance analysis, but they're all around 8% on this task gamma. So we know these ones are their main drivers. These activities are the main drivers for cost. So it tells us if we want to control costs, these are the activities that we should be looking at. Now, the other thing is we can take a look at risk. So what are the main risk driving costs? And we can see the risk that gamma ray job must be repeated. And it is accounting for 62.7% of the risk. And the cost of it is pre-mitigated risk is $250,000. So this one, it's assigned to 10 tasks. We can see those gamma ray tasks. This is the risk that we are going to need to prioritize first to manage cost risk in the project. Finally, if we wanted to take a look at what resources might be causing a particular risk in the schedule, we can go back to the result Gantt if we want, and we can go to, let's go to the gamma ray test. We can look at the resources. If we want to see, we can see what the simulation results are there. Now this is pretty interesting. So we have, this looks to be the next uncertainty, and then there's this long bubbling sort of results, which are probably risk events, some risk events that are occurring. We've got our P80 versus our deterministic, our mean, which is right here. So it does give us an idea about what's occurring. It seems that we have some, a lot of long-standing sort of uncertainty that's driving this risk out there. But again, most of this is occurring at well past the P80. So there's not a big chance that these are going to occur, but that's with that risk event occurring, this could cause that. So at this time, we'll open it up for question and answering. If you have any questions, please feel free to ask them there. Here's some additional resources and my contact details. If you'd like to get a hold of us, please feel free to contact me at the email address mtrumper@entabor.com. There's my number that you can contact me at. We have white papers, articles, online tutorials, and project decisions, which is a additional site that we have that focuses on what we call our non-commercial resources. We do have 3 books that covers a lot of this type of processes and analysis and how to set up and perform decision analysis and project risk management on your projects. We have just released our 2nd edition of Project Decisions, the Art and Science. If you'd like to find out more about it, please visit our site.